let's look at it this way. Say Trump ran against Biden today.
Oh boy.
And they say, and someone says, there's no preference between voters between the two people. No preference at all. So if I take 100 people, how many do I expect to be for Trump and how many for Biden? 50 and 50. Does that make sense? Now, we're saying 5 flavors, no preference amongst the 5, so they should have the same amount, right? So 100 people, how many in each category? 20. Because 100 people, divide them equally amongst 5. 100 divided by 5 would mean 20 in each category. Make sense? Or is everyone kind of following that? Okay, so my expected values, in this case, would be 20 in each category. So first I'm going to state the hypotheses and identify the claims. So again, you're writing this down, so write this down in your notes. Step 1, in your notes, not in the quiz, in the notes, chapter 11 notes. Example, a market analyst wish to see, so page 77, at the middle of the page. Yes? Is everybody there? Yes, no?
Yeah.
Looks like this. The top of the page says 11.1 test of goodness of fit. You don't have to make a chart, that's okay. So your hypotheses is, you don't have a chart, just live with it, yeah.
Can you re-explain what I is one more time so I can break it down?
Right, so I is sort of it means that there's going to be a lot of different labels. So it's observed sub-cherry equals expected sub-cherry. Observed sub-strawberry equals expected sub-strawberry. Observed sub-orange equals expected sub-orange. And you always number them. We say O sub, we call it cherry 1, strawberry 2, orange 3, lime 4, grape 5. So we'd say O sub 1 equals E sub 1. So my cherry observed equals my cherry expecteds.
Okay, thank you.
Okay, so, all right, so here, everyone under step 1, you should have written down H naught, O sub I equals E sub I. H1 is O sub I is not equal to E sub I. My claim is going to be that they are as expected. So they equal what I expect. So H naught is going to be my claim. For the exams, chapter 10, my claim is always going to be H1. For chapter 11, my claim is always going to be H naught. So you kind of think of, 10 goes with 1, 11 goes with 0. They kind of balance each other out a little bit. All right, so here, chapter 11, my claim is always going to be H naught. That's for the exams. The same is not true for your homework. Your homework will do whatever it wants to do, so no promises there. But for the exams, my claim is always going to be, for chapter 11, H naught, and for chapter 10, H1. Okay, so everyone has this first part written in. Step 2, find my degrees of freedom. Let's see, I have 5 categories. So my degrees of freedom is equal to 5 minus 1. That's 4. My alpha is 0.05. Incidentally, if I don't give you an alpha, the generic default alpha is 0.05. It's our general guideline for unusual, unless I give you something specific, something otherwise. If I don't give you one, assume it's 0.05. All right, so now I'm going to bust out my chi-square table, and oh look, there's all sorts of, there's a lot of different things there, right? 0.995, 0.990, all these other ones. So the first 5, just cross out the top rows. We're never going to use the top 5. The first 5, sorry. And I just cross out the top of them so that you don't get them, just you don't use them, And then we're also not going to use the last one. And we're also not going to use the 0.025, which is the second from last. So I'd say cross out those ones there. Yeah, but I just cross out the top, because if I cross out the top, then I won't use the column. You know what I mean?
So the first 5.
The first 5 and the last one, and then the 0.025 one. We're not going to use those ones. So that'll save you from getting mixed up and using them. All right, so we want alpha's 0.05, so that's the fourth from the last column. And my degrees of freedom is 4. So I want to check and see what you get. Find it, find it, find it. I get 9.488. Okay, great. So my critical value is equal to 9.488. And then we're going to draw a little picture. Here's a little picture. So the picture goes like this, folks. It goes up, and then it kind of drifts off to the right. Always. So I just kind of go up, and I drift off to the right. And that's my 9.488. Shade off to the right. Now I need to compute the test value. So you have a little bit of room in there to write this. So start at the far right so you have enough room. My test stat is equal to my first observed, cherry, 32 minus 20 squared over 20 plus 28 minus 20 squared over 20 plus, you should be writing this down with me, 16 minus 20 squared over 20 plus 14 minus 20 squared over 20 plus the last one, 10 minus 20 squared over 20. All right, so this is right on the edge of where I might use my calculator instead of just doing it by hand. But on the exam, you're only going to get 3 or 4, so it's really easier to do it by hand anyways. And you're going to have to write these down for me anyways. Part of your stuff, you're showing your work is writing this part down so that I know that you understand where this number comes from. So you have to do this step here, writing it down. Okay, so then I gotta look through this, and luckily these numbers are pretty easy, so it's not too bad. 20 is easy to work with. So 32 minus 20 is 12. 12 squared is 144 over 20, plus 8 squared, 64 over 20. 16 minus 20 is negative 4, but once you square it, it becomes positive, so I kind of ignore the negatives here. So 4 squared is 16 over 20. This is a difference of 6. 6 squared is 36 over 20. And 10 minus 20 is 10, so 10 squared is 100 over 20. If I add those up, we'll get 64 and 36 is 100, plus another 100 is 200. 360 over 20. And the zeros will kind of cancel out. I'm left with 36 over 2, which is 18. All right, so we got 18 here. Where does 18 fall on my picture? Way out here. 18. That's my test stat. So what do you think, folks? Should we reject or not reject?
Reject.
Reject. It's totally way out there. It's unusual, right? So we're going to reject H naught. This is my step 3. So step 4, reject H naught. And then step 5, since I did reject H naught, I do have enough evidence. Yeah, evidence to reject the claim. Well, I'm going to make it easy for you. That there is no preference. Between I will also let you get away with this if you wanted to. You could also say claims alternate of that proportions are as expected. I will let you generically use that for all of 11.1 and 11.2, for all the chi-squares that you prefer. You can use either one. Okay. Give folks a minute to kind of sort that out. Yeah. Okay.
So the claim that we're making is that there's no preference. So then the observed values should be the same as the expected values, so it takes none.
So, and then just pick on always H1 of the car, and you just pick your
So they're the same.
Yes.
Thank you. No problem. So it's the same one. It's the same one.
So here's another thing. Let's talk about the expected frequencies a little bit. So first of all, our expected frequencies is NP. So the number of items we have, the number of people we asked, multiplied by the probability for that category. If all the expected frequencies are equal, then if there's 5 categories, the probability of being in any category is 1/5. So the number of people you have multiplied by 1/5, which is the same thing as just dividing by 5, right? You're equal among 5. But let's take a look at about what expected values can be. So first of all, if I flip a coin 5 times, what are my possible outcomes? What are the categories?
Heads or tails.
Heads or tails. Perfect. So my K is what? How many categories do I have? 2. Great. What's the probability of getting a heads? 50%. Tails? Great. If I flip a coin 5 times, how many heads do I expect to get?
2.5.
2.5. I expect to get 2.5 heads. How many tails do I expect to get? 2.5. Expected frequencies do not need to be whole numbers. Expected frequencies are the ones that you calculate. So the expected frequencies are the ones you find by calculating, by multiplying things or dividing things, and they do not have to be whole numbers. Observed outcomes have to be whole numbers. They must be whole numbers. You're never going to observe 2.5 heads. It's going to be either 2 or 3. It's going to be a whole number. So the observed, so what you actually get, are always going to be whole numbers. The expected frequencies can be decimals. Who's ever heard of the average family has 2.4 children?
Yeah.
So you can expect to have 2.4 children. You can never actually have 2.4 children, right? You're going to have a whole number of children. So what you observe will be a whole number, but you can expect a decimal. Good? Right. So in this case, they gave us one where it's not equally preferred. It's going to match up with some percentage in each group. So here we've got, let's get a reader. Who should I grab? Austin, you haven't read in a long time.
The Census Bureau of the U.S. government found that 13% of adults did not finish high school, 30% graduated from high school only, 29% had some qualifications but did not obtain a bachelor's degree, and 28% were college graduates. To see if these proportions were consistent with those people who lived in the Lincoln County area, local researchers collected a random sample of 300 adults who did not finish, 23 did not finish high school, 76 were high school graduates only, 96 had some college education, 4% of the safety adults in Lincoln County as those stated by the Census Bureau.
Good. All right, so I have 4 different groups of people. What are those 4 groups?
Did not finish high school.
Right, so no high school or not high school.
High school.
High school graduate. What else?
Some college.
Some college. And I'll call it college. Okay, good. So, so you should make yourself a little table like this. This is an example. You folks are doing this one with me also too, right?
Yeah.
So make yourself a little table like this. And then you're giving us our observed. So our observeds are, let's see, what do we got? We have 43 did not finish high school, 76 were high school graduates only, 96 had some college, and 85 were college graduates. Okay. One quick comment for the first comment I'm going to make is, see how you have 4 things that percentages and then 4 other numbers?
Yes.
And they match up. It goes not high school, some college, college. Your homework will have 1 or 2 problems where they have mixed up the orders. So the order in the first one will not match the order in the second one. So they might go, one might go not high school, some college, college, and then the other one will go college, high school, some college, not high school, or something like that. It'll move them around. Be aware of that because I had a student who just spent literally over 2 hours on one problem, doing it over and over and over again, and could not figure out what was wrong. And it's because she didn't realize they'd mixed up the order on her. Okay, so just be aware of that happening. Okay, so let's take a look. So that's my observed. My observed are whole numbers. You're always going to be given the observed. I'm just going to give them to you. Here are the numbers. Done. The expected you have to calculate. So let's see. My expected, not high school, 13%. High school, 30%. Oh, wait, 13%. Make it smaller. 30%. 29%. And 28%. Now, is it fair for me? Does that seem right?
No.
Is it fair for me to compare 43 to 0.13?
No.
And to compare 76 to 0.30?
No.
Those are never going to be equal. What should I do about this?
Divide each row by 300%.
What was that?
Divide each by the rectangle 300%.
Ah, so change the top one to percentages? Right, and that's something that people want to do. That's a common logical thing to do, right? Make them all percentages. Here's the problem, is that each category has to have 5 or more in it. My expected value has to be 5 or more. Because if it doesn't, then you've taken n, the sample size, out of the equation, and you're basically dealing with the sample size of one person, and a portion of a person is in each category. I had a student in the math lab a number of years ago, back when we were still, like, we were meeting in person, right? And she was like, why is my chi-squared always less than 1? I'm like, because you're talking about portions of people, so you're always going to have you're talking about a really small number, subtracting another really small number, squared divided by another really small number, you're always going to get tiny numbers. So she would never reject h naught because she'd always get this really small chi-squared that was like less than 1 every time. So that's a good idea, and people want to do that. You can't do that because you've taken the n out of the problem. The second problem is that these have to be 5 or more. So instead, what's another thing we can do instead?
You can multiply these by the 300.
Exactly. So 13% of them should not have a high school degree. 13% of how many? How many people do we have here? 300. So is that understanding where I got the 300 from?
Mm-hmm.
43 plus 76 plus 96 plus 85 is 300. So 13% of these people I expect to be not high school graduates. So 13% of 300, of means multiply. So 13% times 300, that's 39. %30 of 300. That's 90. 29% of 300. That's 87. 28% of 300. That's 84. So that's how many I expect to get. Everybody has their tables all written in now? Okay. All right, so let's do step 1. My H naught is what? And my H1 is what? Write those in. Fill that in, fill it in, fill it in. You should know this by now. I'll start you off. O sub I. H naught is always, always, always equals. So O sub I equals B sub I. And what's H1? Not equal. My claim is going to be H naught because for chapter 11, that's always going to be my claim. I'm going to use the word reject later on for step 5, sorry. All right, step 2. Step 2, I need to find my critical value and draw a picture. So here's my picture. My degrees of freedom, I have 4 items. My degrees of freedom is going to be 4 minus 1. That's 3. What's my alpha? 0.01. So I pull out your sheet, your chi-squared. 0.01, that's like the 5th, that's kind of right in the middle. First, open one, find your critical value.
Pi or pi? Oh.
There's 4 categories.
It's pi 1
Is that?
Oh, it's pi 1 not pi 1.
What?
Alpha is pi 1 yeah.
What?
Alpha is pi 1 This one.
Yeah, 1
Okay.
So I end up with 6.251. 6.251? Step 3. Find my test stat. So it's going to be every expected minus observed minus expected squared divided by expected. You know what, I'm going to do this the lazy way. Now I'm going to pop it in my, now that I've written it, I'm going to pop it in my calculator. Okay. And the nice thing is, because of how it works, with the parentheses around the top, like the squares, you can just put them straight in just like it is. So you can do it with me if you like. I'll show you how to do it. So the first one is 43 minus 39, so parentheses 43 minus 39, parentheses, oh what's 39? Squared, raised to the second power, divided by 39. Plus, next one, parentheses, so it's 76 minus 90, 76 minus 90, oh, I'm not going to take it right in. Minus 90, oops, squared, divided by 90, plus, parentheses, next one, 96 and 87, is that right?
Yes.
96 minus 87 squared divided by 87 plus, well, actually it's just 1. 85 minus 84 is just 1. 1 squared is just 1. 1 divided by 84. Perfect. Hit enter. Bam, there I have it. 3.531. So you should have all been practicing doing that on your calculator with me.
Wait, what? What did I do this from?
So you just put the parentheses in where they go, and it kind of works out. If you find you're screwing up, you can do it each individually and add them. It's fine. Okay. So now, where does 3.531 go in this picture? Right, and this empty area here. 3.531. So am I going to reject H naught or not reject H naught?
Do not.
Right. So do not reject H naught, which means that there is not enough evidence to reject claim. Yep. To reject claim that, and again, you can just use the simple generic one that proportions are as expected, exactly. Okay. Everyone okay about this? Are you folks ready to do one of your own? Oh, here's a quick summary. All right, so here's the, so Zoe needs it, and you're going to look at it, and we move on in like 5 seconds. 5, 4, 3, 2, 1. Okay, so here's the summary. Summary steps. So step 1, H naught O sub I equals E sub I. H1 is O sub I is not equal to E sub I. Step 2, find your critical value from the chi-squared table using degrees of freedom of k minus 1. Step 3, compute your test stat. The sum of O sub I, O minus E squared over E. Right, if you're observed as close to your expected, that's going to be a small number. That's what you're aiming for. And then decide if you're going to reject the null hypothesis or not. And then summarize your findings for the claim. All right, so go ahead and hop in and work on, you have 2 problems to do. Here's the first one. This one, take a look at it. You'll see 74%. 74% of how many? Yeah, you got to add them up. 62 plus 23 plus 5, 90.